Hi everyone, this is lesson 1.3. We're going to learn a few more exponent laws. All right, let's just get right to it. So if I want to look at 1a and I'm being asked to expand using repeated multiplication, if I have 6 to the power of 3, I know that the base is 6. I'm repeating it 3 times, 6 times 6 times 6. Same with 2 to the power of 3. I would take the base of 2 and repeat it 3 times. What happens when I get 6 to the power of 3 and 2 to the power of 3 multiplied together? Well, I can see that there's actually a shorthand way of writing this, which I'm being asked in part B. Yes, there's definitely a compact way of writing this, because if I pair up the 6's and the 2's, I can see that this is actually the same as 12 to the power of 3, because each of these multiplies to 12. So yes, there is definitely a compact way of writing 6 to the 3 times 2 to the 3. I can write it as 6 times 2 to the power of 3, or 12 to the power of 3, exponent 3. This leads us to a general rule for multiplication, which I'm going to write here. So if I have a base of a to the exponent n, and I have a base of b to the same exponent n, I can write that shorthand as a times b to the power of n. That'll help me simplify it. A very similar thing happens with division. If I were to expand 6 to the power of 3 using repeated multiplication and 2 to the power of 3, I can see actually that this is 6 over 2 times 6 over 2 times 6 over 2, which is actually 3 to the power of 3. So yes, there's definitely a compact way of writing these two powers that have the same exponent but a different base. So if I were to generalize this law, if I again have a base of a raised to the exponent n and a base of b raised also to the same exponent n, and they're being divided, I can write it as a over b to the power of n. You'll more likely see this written, oh, sorry, I was confused there for a sec. Okay, let's try to use these laws now. So I have the same exponent and two different bases. I can multiply the bases together and raise it to the same exponent. Now, if you recall in our last lesson, we don't want to write this as a negative base. So right now I can see this as a negative base to an odd exponent. If I were to write this without any brackets, I know overall my quantity is going to be negative. So I can write it as negative 32 to the power of 17. Similarly here, I can write this as 8 times negative 3 to the power of 4. 8 times negative 3 is negative 24. But since the exponent is even, I can write this without brackets as 24 to the power of 4. Let's try our division rule. So as long as the exponents are the same, I can simplify by dividing the bases, and this is 3 to the power of 20. And here again, we have the same exponent. We have division. 21 divided by negative 3 to the power of 8 is negative 7 to the power of 8. I have an even exponent. The exponent 8 applies to the negative and the 7, meaning I can write this as positive 7 to the power of 8. So we've just added two more exponent laws to our list of laws. We're going to add one more here, the exponent of 0. So if I were to explore these two examples, 5 to the power of 3 divided by 5 to the power of 3, I can write this in two ways. I can write this using repeated multiplication, or I can write this using my exponent law, which tells me I need to subtract the exponents. If I simplify, I'm going to do this in a different color. So if I were to simplify my red writing, I know that my final answer is 5 to the 0. But if I were to simplify my blue writing, I would cross out the numerators with the denominators, and I would get 1 over 1, which equals 1. So I've done this question two different ways, but I know my final answers, since these should be equal to each other, are the same. What I conclude here is that 1 equals 5 to the 0. Let's try this again with a variable as our base. So if I have a to the power of 7, exponent 7, divided by a to exponent 7, I can write it in two ways. I can write it using repeated multiplication, 1, 2, 3, 4, 5, 6, 7, over 1, 2, 3, 4, 5, 6, 7. And I would know that all of these guys cancel out. I'm going to get 1. But if I use my exponent law as 7 minus 7, my final answer is a to the power of 0. And in fact, this gives us our general rule. If I have a base of a, any base raised to the exponent of 0 is going to give me a value of 1. And the reason being is because that means there are the same number of bases repeatedly multiplied in the numerator as there are in the denominator. So they will all cancel out. So we have 3 new exponent laws. Let's put them to practice with some practice questions. So anytime I see an exponent raised to the power of 0, I know that that overall result is going to be 1. 3 to the power of 0 is 1. 1 to the power of 0 is 1. 5 to the power of 0 is 1. And here, my base is -6, and -6 to the power, if a was -6 in this rule, I would know that overall my result is going to be 1. So this ends up being 4. Now remember, with BEDMAs, we know that operations with equal priority, we do them from left to right. So I have multiplication and division here. They have the same priority, meaning I have to do my work from left to right. So I have to multiply these first two powers, 3 to the exponent 5 times 4 to the exponent 5 first, and then I divide by 12 to the exponent 4. So using my rule, I know that I can write 3 to the power 5 times 4 to the exponent 5 as 12 to the exponent 5. And now I can use my exponent laws to subtract the exponents here. All right, let's look at C. So before I do anything, let's recognize that that is a term all stuck together. So in this question, there are 3 terms. The first 2 terms simplify as 1 plus 81. Now we'll simplify 3 to the power of 2 times 3 to the power of 3. Well, I know that is going to be 3 to the power of 5 when I add the exponents. 9 to the power of 0 is just 1. So this ends up being 1 plus 81 plus 3 to the exponent 5. And 3 to the exponent 5, I believe, is, oops, I was way off, 243. And let's add those together. 325. All right. Here's a term. And then everything in this bracket is glued together. So I have the same exponents here, 4 and 4, so I can multiply the bases together. 8 to the power of 4, subtract -2 to the power of 0 is 1. And I have the same exponents again, so I can divide the 15 and the 5 to get 3 to the power of 3. 8 to the power of 4, 8 to the exponent 4 is 4,096 minus 1 plus 27. All right, that's 4,096, subtract 28. So we get 4,063.